Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to go over how to add and subtract radical expressions. So let's go ahead and begin. So the principle behind this is that you have to deal with the radical expression and you have to deal with other numbers that may be involved. And the key to start with, the first principle is that when they have the same base, you can just add them like regular numbers. So let me see if I can give you an example here. If I go ahead and do this, so let's say I have 5 times the square root of 2 plus 3 times the square root of 2. Now I said base a minute ago, but that's actually a mistake. What I meant to say was the same radical, or yes, the same radical. So you can see here that the radical here is 2, the same radical is 2 here. Also notice how they have the same index. Now remember, when it's square root, we don't put it, but technically this is going to be right here, a little 2 here. And so since everything is the same, you just add across and you get 8 times the square root of 2. That's it. And the same principle applies if you have a different index, if you will. So to give you an example, let's say I have cube root 3xy plus 5 cube root 3xy minus 4 cube root 3xy. And so again, this is basic addition and subtraction. So we add first. No, excuse me. Do we add first? Yes, we add first. So, there's not a number here, but basically this should be a 1 here because that's how it is. So 1 plus 5 is 6. 6 minus 4 is 2. And now why do we do that? Because we have the same index in each example and we have the same radical inside each example. That's how it works out. So our answer would be basically 1 plus 5 minus 4, which the answer for that would be 2 cube root 3xy. Very simple so far. However, life is not always that simple. Sometimes we have different radicals that we have to deal with. And so in that situation, let me give you one example here. We have the square root of 18 plus 6 times the square root of 2. What does that equal? Well, the first thing is that we want to factor out, or at least partially factor, maybe not completely factor out one of these. And our goal is this: when we can get it to the point where both sides have the same radical, we can complete it. Now, that sounds kind of weird right now, so let me give you an example to make that clear. So the square root of 18 can be considered as follows. You can have the square root, let me give you a different color here. We have the square root of 9 times the square root of 2 plus 6 times the square root of 2. All right, now, here's what's happening. We're already making significant progress because you can see right here, we got this base right here, square root of 2. And the beautiful thing is this, is that the square root of 9 is going to come out to 3. So we end up with the following if we just follow the steps here. We end up with square root of 9. Square root of 9 becomes 3. Then we have the square root of 2 plus 6 times the square root of 2. And now you can see right here that we have the same radicals here. And now we can add straight across like in our first example. So we end up with the final answer of 9 times the square root of 2. That's the beauty of it. So there's a little bit of a pre-step there that you have to take in order to complete this. Let's do one more example like this before we move to our final concept. So let's say that we have the following: 6 times our cube root times the cube root of 16. Yes, 16 minus 2 times the cube root of 250. Now this looks huge, it looks complicated, but again, we just do our basic principles. So this is what we do. We got to factor both this time. Last time we only factored one, but this time we factor both. And so what we do here is we have 6 again. That's going to be out here by himself basically, times the cube root of 8 times the cube root of 2 minus 2 times the cube root of 125 times the cube root of 2. Now, if you're watching closely, we're getting close here because we have the same cube roots here on both sides, which is going to be good because these cannot be simplified anymore. However, we also have something that can be broken down into a basic whole number here, because we know that the cube root of 8 is going to be 2 and the cube root of 125 is going to be 5. And so here's what we get for our answer as we continue to break this down. We have 6 times 2 times the cube root of 2 minus 2 times 5 times the cube root of 2. You guys can see what the answer is now, hopefully. And so if I continue working with this, I got 12 times the cube root of 2 minus 10 times the cube root of 2. And our final answer is going to be 2 times the cube root of 2. That's what we end up getting for our final answer, because 12 minus 10 is 2. And so you can see how the process worked out. It was a little bit more complicated, and you really have to think about certain things. So for example, you have this cube root right here. Well, you know that you have to find something multiplied by itself 3 times will give you this little, give you the radical right here. And so it takes a little bit of thought, and you have to kind of see the patterns at times. Let's do the last one. This last example is going to involve variables this time. So far we've only been working with, constants, whole numbers or whatever, but now we're going to have a mixture of constants and whole numbers as we calculate this. So let's go ahead and take a look at this. So we got the cube root of 3, and it's going to be 54 into the 5th power. That's what we're going to do here. Into the 5th power minus 3 to the cube root of 16 to the n to the 5th power. All right. Actually, this is going to be plus. We'll do the plus. Okay, so what do we do first? Well, we got to factor both sides like before. So we want the cube root of 27 into the 3rd times, let's see here, the cube root of 3, it's cube root of 3 times 2 to the n 2nd power. Now, notice something that's happening here that we have not seen before. This time, because we have a higher exponent, we have 5 now, we have to spread that across. And now the criteria is this: by putting this here, again, we're looking at the pattern, what's going to happen is this. We put the 3 here, we put the 2 here, 3 plus 2 will equal to 5, the original number. But watch, because we're doing the cube root, what's going to happen is that the 3's are going to eat each other here, and so I'm going to be left with n. And then I'll have the cube root of 27, which is going to be 3. So there's a reason why I put it to the 3rd power for this one. This one is kind of my base already. There's no more reducing of it that I can do as of right now. But let's just keep going here. So plus, and let's see here. We're going to have the cube root of 3, 8, n to the 3rd, times the cube root of 3 to n squared. And again, it's the same idea here. I put the cube here because what's going to happen is that when we simplify, this 3 and 3 will kill each other, they'll eat each other, and I'll have the n here. And then when I do the cube root of 8, I'll get a whole number 2. And then also I have my base right here, the same base as the other side. So you can tell that I'm getting close. So let's keep going here. So what's going to happen? This is going to reduce to 3n. I just explained that. What's happening here? Into the cube root of n to the 3rd is going to be n, and the cube root of 27 is 3, times the cube root of 2n squared, plus, here we go over here, same experience, this is going to become 2n, right here, because the n to the 3rd and the cube, they eat each other, and then 8 cubed is 2, times the cube root, I don't need those, I normally just put it like this, here we go, times the cube root of 2n squared. Now it's just a matter of adding them across, because we have the same basis now on both sides. So you know that our final answer is just going to be very simple. 5n times the cube root of 2n to the 2nd power, like so. And essentially we are done here. And so let me go back and try to explain what we've done in this video so we can move on. In this particular video, we looked at how to deal with adding and or subtracting radical expressions. And so the main thing is this, is that when you're dealing with your terms, no matter how many there are, they must have the same radical. If the radicals are the same, you can add or you can subtract across. Sometimes you have to do a pre-step. Like in this first example, no need for a pre-step. Everything was set up for us. However, in this second example, we had different radicals. And so we had to address that first by doing some factoring. Once you get to the point where you have the same radicals for all your terms, it's a matter of just going back to the original idea of adding across or subtracting across or doing a combination of both. And so, again, this is just a more complex example where instead of having the square root, we have the cube root, but the same ideal applies. You have to make sure that you start to get the same base on both sides, the same radical on both sides. And it has to be a radical that cannot be simplified anymore. And then once that is in place, you add or subtract across as necessary. And then of course, when you're dealing with this situation right here where we had variables and also we had higher order, higher order exponents. In other words, we had exponents that were not the same as the index. You first have to, of course, do the factoring again, but you have to keep in mind you have to try to find a way where you find a radical that has the same exponent power as the index, and hopefully, if possible, the whole number that is inside the radical will also be a perfect cube or a perfect square root, perfect square, whatever it is. And then when you have the same basis we've already talked about and you simplify everything, you add across like before. So that's how this works out. So I hope that this video was useful for you and that you were able to understand some of the principles that you need to keep in mind when trying to add and subtract radical expressions. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.